So you've been asking really good questions, and one of the big questions you've been asking that I really want to address right now is what if we don't know if the data is normally distributed? Is there a way to show or prove that it's normal, and will all data be normal? So to answer the last question first, no, every data set will not be normally distributed. If it's not normally distributed, then I cannot use the normal curve. If it is, then I will. But what we got to look at is how do I show or how do I prove that something is normal? I'm going to start with my graphing calculator. So on my graphing calculator here, where I need to go first is go to stat, and then stat comes up and the first option is edit. So you go stat, enter, and it gets you to the list of lists here. So you'll see that I have a data list. There's something there is in list 2. I can't remember what this data list was from. But anyways, so there's my data in list 2. And what we're going to do is see, is this data set normal? And what we're going to do is we're going to take this data and we're going to plot it. And we're going to do a special type of plot called a normal probability plot. So what we're going to do is go second y equals to get this screen. And what we're going to do is go to plot 1 and we're going to turn it on. All right, and once we're in plot 1, we're going to select, well, let me show you. All right, so I selected plot 1. First thing I'm going to do is turn it on. And then this last plot, so it was dot plot, line plot, histogram, modified box and whisker. This is what's called a normal probability plot. A normal probability plot takes, here's what it does. You don't have to do it by hand ever. But it takes your X data and says, okay, well, if your distribution is normal, then it calculates the z-scores for every data point in there and makes that into a second list. So what your lists are, when it plots it, it'll plot it on a, like this. Well, we'll look at it here in a second. But it will plot it like this, and the X list is the data, and they plot it with the corresponding z-score. So if I had a data point here of 400, comma, negative 0.2, that means if the data were normal, the data point of 400 would have a z point of a z standardized normal value of negative 0.2. And it will plot all of this data. So I selected the list where my data is. Remember, I had it in list 2. So I'm going to do list 2, X, for the data list. I'm going to mark it with donuts because, of course, I like donuts. And then I'm going to do zoom, then the number 9 to get this graph. And once I have the graph, then I need to interpret what it says. All right, so this graph, if I hit the trace button, it tells me that this data point right here from the data set I have is 330 for my X value, and my z-score is negative 1.73. All right, you can see that data point is below the 0, so the negative, it's a negative z-score, which also means that it's below average. So whatever data point is close to being on the line is right near what the average X value is, because it have a z-score of about 0. But anyways, when I do a normal probability plot, this is what I want to look at. If the data follows a normal curve, then this plot will be approximately linear. All right, so I look at this graph and I go, okay, how would I describe this graph? Is this graph approximately linear? And the more we do it, the better you will be at estimating. But I'll tell you right now that the answer is yes. This is approximately linear. So this is what I would say if I were doing a problem related to this. I would say, since the probability plot, or normal probability plot, is linear, then the distribution of, and I think these were SAT scores, because I always want to have context, always got to have context in there. So since the probability plot is linear, now it probably wouldn't be a bad idea for me to throw in the word approximately. All right, and if you're ever doing this on a test, do that. Don't erase things. Just arrow in a new word. Totally fine. Not a problem. All right, so since the probability plot is approximately linear, then the distribution of SAT scores approximately follows a normal curve. Or I'd say that the distribution of SAT scores is approximately normal. All right. When you're doing your interpretation of graphs, don't say, since the graph is linear. Is this a graph? Yes, but don't call it the graph, call it by its proper name. Just like when I talk to you, I don't say, hey, you, boy. I address you by your first name. All right, so since the probability plot is linear, or approximately linear, then the distribution of SAT scores context is approximately normal. Okay? Some mistakes that I see when people interpret these is they'll say, oh, since this graph is normal, well, look at it. It's definitely not normal, because normal would be like this. And you can clearly see that that data does not follow a normal curve. All right? So you can't say since it's normal. All right? Since the normal probability plot is approximately linear, then the distribution of SAT scores is approximately normal, or approximately follows a normal curve. If I show that a graph is normal, then I can use the z-score, and then I can find properties. All right, so if I know that it's normal, then I go, oh, my z-scores, I can do this, and whatever the average was of those, of that data set, I can go, all right, well, if I do a calculation of it, the actual average was 536, and 1, 2, 3 standard deviations, 1, 2, 3 standard deviations. And then I can do a z-score formula, x minus mu over sigma, find that approximate z-score, and then find areas from the z-table like we did in the past. The ability to show that something is approximately normal is good. On the AP exam, it's unlikely that I'll ask you to actually enter data and make that plot. Instead, what will happen is you'll be given something like that. And then we'll be asked to interpret, and this will be X and this will be Z, and they'll say, based on this information, what can you tell about the distribution? So I look at this and say, okay, there's actually a very clear pattern going on there, and it's actually not linear. So in a case like this, I would say, well, the normal probability plot shows a very clear curved pattern, which means that the distribution is likely not normal. All right, maybe I even have a data point way out here, very skewed. All right, so maybe I have it really good, lots of data here, very, very linear, and then also it's like we get a couple data points way out there. All right, something like that. Then very clearly not linear, very clearly skewed to the right. These are outliers in this direction, so very clearly skewed to the right, which means that the distribution is not normal. So that is something that we might be able to find out from looking at these graphs and what to do with the normal probability plot. So this is how we assess normality. What I want you to do is take a look in your textbook. What I want you to find is what they indicate is the, quote, definition of a normal probability plot. All right? I want you to summarize that. Summarize and put that in the reflection response for the question that I'm asking you. All right? So summarize what they say in the normal probability plot for what it is, or in how to interpret. You know, that's really the big thing, is how do you interpret a normal probability plot. So synthesize and write that down, and we'll see you in class.